Hello, everyone. I hope all of y'all are doing well. My name is Kelly Welch, and this is Science in GSS for our presentation today. The three technologies which I have incorporated is the Prezi that you now see, the pictures, and then this video, and also a Google Docs at the very end, which I've created just as a picture. But anyway, though, Science in GSS. So what I used to think. Sorry about that. It took me all the way back to the end. So what I used to think, I used to categorize science as life, physics, chemistry, and earth, which is, of course, appropriate. But what I did not appreciate science as I do now. I thought of science as something that is kind of in a textbook, and for scientists, I think of chemistry, biology, physics, just the different high levels of science. And that is true, but science is seen in everything around us. And one of the most important things for students to understand is for teachers to understand, is that we need to make it real to our students. And that is probably why I did not appreciate science as well. But now, so what I know, as I said, science is seen in everything around us. Lightning has electricity. I mean, we see flowers, leaves, trees, grass that grows, even the dirt. I mean, it's all science. And so it is not just a subject to be taught, but to be experienced. And the good thing about NGSS is that it forces students to critically think about the outcomes, to think about just experimenting with whatever is being taught, and then so what. So science, as I said, should not be taught, but students should be able to have firsthand experience to demonstrate science and engineering. So they need to learn the science, and they need to act on what they have learned, such as using the 5E model, which is engage, explain, evaluate, elaborate, not in that order, but all 5 of those are very important for students. And then here is the NGSS graph that I copied from Bozeman's science video. And he is just simply sharing that concepts, ideas, and practice should not all be in an equal group. They're both equal, and there should not be more concepts or lessons than there is practice, or ideas than there is practice. They all fall equal. Cross-cutting concepts are the different types, such as patterns, cause and effect. This is how students are able to look at the science lesson and then determine, and then there's different types of things for the experiments. And then disciplinary core ideas, of course, that's the different sections of science: physical science, life science, etc. And then so for my follow-up, if you could post a picture on the discussion board and write 3 to 5 sentences of how this picture reflects on science, and then how you could incorporate the picture into your classroom. Here's my works cited page. And one thing I would like to add that I did not put in this Prezi, that the North Carolina standards of science we have today, even though they are good, they do not focus on how to explain, or how students can explain and to critically think about the science and put it into real-world application as the NGSS does. And that is the NGSS would be the perfect standards for the 21st century, because students need to critically think, and they need to apply what they learn to real-world events, because of course students will be able to learn and to remember the information instead of remembering it for a test and then forgetting about it. That is not how we should do things anymore. And thank you very much for listening, and I hope y'all have a great night.